Hi, I'm Vijay Mamilla. This is a QueryMind AI, my capstone project for the Codebasics AI Engineering Bootcamp. QueryMind is a text-to-SQL analytics engine. It converts plain English questions into SQL query and run them against a real Postgres database. No SQL knowledge needed. Let me walk you through what I built it, and show you a live demo. The problem statement. The problem I'm solving is a real common. Business analysts need a data insight, but they can't write SQL. That creates a bottleneck where the data team spend half of their time answering ad hoc queries requests instead of doing a real analytics. Traditional BI tools like a Tableau require pre-built data boards. They're not flexible for open-ended questions, and the existing natural language interface lacks guardrail. You can't just let user run arbitrary SQL against a production data without any controls. Query might solve all of this. Type a plain English questions and get results in about 3 seconds. Runtime guardrail prevent a dangerous operation like delete. Every query is fully logged with the generated SQL and latency. Everything is configurable through an admin interface. No code change needed. If the SQL fails, it automatically retry with the error feedback to the LLM. The architecture. The core of the query mind is a 7-stage module pipeline. Let me walk you through each stage. Stage 1, classifier. Detect the intent of the question. Is a simple SQL select, an aggregate with a group by, multiple table join, and temporal query, or something that should be blocked entirely. Stage 2, Schema Linker. Map the entity mentioned in the question to real table and column name in the Postgres database. So revenue map to the total amount. Customer name map to first name plus last name. Stage 3, retriever. This is the RAG component. It embeds the question using the OpenAI text embedding, and this is the LLM I'm using for embedding model. And then for search, I'm using a quadrant for retrieving the semantic similar queries. Let's assuming that you give few sample questions. If similar search is available, it will retrieve from quadrant. Next is stage 4, generator. Build a structured prompt with the schema retriever example and the user question, then call GPT to generate SQL. Stage 5, validator. Checks the SQL using a sqglot AST parser for syntax error. Validates the table and column name against the live schema. Enforces the guardrail rules. Select, allowed, delete, blocked. Next is the key features. 6 features make QueryMind product ready for production. Few-shot RAG. Instead of fine-tuning, retrieving the semantically similar fast example at a query time, 30 query example across the 4 different type of query types stored in the quadrant, retrieved by a cost similarity. This is dramatically improves the SQL accuracy. Next is a runtime guardrail. Each SQL operation, they can be toggled on or off through admin interface. Max the number of rows. It can give the results. There are enforcement at the validation stage. They can't be bypassed any clever phasing. Self-healing SQL. If the generated SQL fails on execution, the error is automatically fed back to the GPT for one retry. This handles the most real-world failure like a column name mismatch silently. Full audit logging. Every single query is recorded. You can see exactly what SQL was generated, whether it is succeeded or blocked, how many rows were returned, and how long it took. Document injection. You can upload a schema document as a PDF or a docx using a doclink parser. It can index into quadrant, so LLM has a richer context when generating SQL. And then runtime configuration. Switch the LLM model, dialect, temperature through admin interface. No server restart is required. Next is admin panel. The admin panel has a 5 management screens, all built in React with the Next.js and then Tailwind CSS. The first screen is Schema Manager, shows live database schema pulled directly from the Postgres. You can add a description, synonyms to the column, which helps the LLM understand the domain-specific terminology. For example, tagging total amount with the synonym revenue means that user can ask, what is the total revenue? And LLM correctly map it. Example manager. This is where you manage a few short queries SQL pair. You can add, edit, or delete example. Trigger a full resync to the quadrant. I have preceded 30 examples. Query log. A full audit trail of every query. You can expand any row to see the exact SQL that was generated, filtered by success, error, or blocked status. See the latency. Guardrail config. Control panel for SQL permissions. Toggle operation on and off in real time. Changes are immediate, no restart is needed. Model config. Switches between different LLMs from GPT-4 to GPT-4 mini, or change the dialect from one to another, or adjust the temperature from 0 to 1 or 0 to zero point 0.5, like that. All runtime configurations can be done through UI. No restart is needed. Next is evaluation results. I built a formal evaluation harness with the 25 ground truth questions to SQL pairs, converting all 4 query type. Simple select, aggregate join, temporal query, headline result is 100% education accuracy. Every single query ran successfully and returned correct data. The exact match is 8%, and this is expected, not a failure. Pipeline automatically append limit 500 rows to every query as a guardrail. That differs from bare ground truth SQL, so it doesn't count as an exact match, but actual SQL logic is correct. Breaking it down by a query type, all 4 category achieve 100% execution accuracy, simple type and aggregate type, join, temporal, all working perfectly. The evaluation harness at eval/run_eval.py in the repository can be rerun against any live backend instance at any time. You can see the in the screen that what are the different query types. You can able to see. Okay. Next is a live demo. We will go with the simple queries, then aggregate type, then we'll go with joins, then we go with the temporal. Okay. And now uh, what I will do is I will switch to my browser view, and yeah, before going there, I will finalize it, the demo, then I will go to the demo. Sorry, finalizing the presentation, I'll go to the demo. Okay. As far as just summarizing the QueryMind is, it is a complete 7-stage text to SQL pipeline with the self-healing, quadrant-powered RAG with the 30 query-rated few-shot examples, runtime guardrail that actually block the dangerous operation at validation layer, full audit logging of every query, a React admin panel with the 5 management screens, 100% education accuracy on a formal 25 query evaluation, and document injection for a schema-aware SQL generation. A full source code is available in the GitHub, which is mentioned in the URL, as well as YouTube video, which I am recording. I can able to put this video link in the GitHub readme.file. Okay, let me switch to the web browser to showcase my demo. Okay, let me go to the code. This is my VS code, which contains different directory structure. Currently, I am using the Docker to run Postgres database as well as a quadrant. Let me click on the Docker compose file. Docker compose file consists of Postgres database, quadrant. Quadrant is a vector database. Okay? It is persistent to the volume. If I go to the Docker desktop, you can able to see, okay, this is running QueryMind Postgres database and QueryMind quadrant. Okay. Now it is divided into the backend. Backend contain all these different components, and then eval. This is where it contains. Then front end. This is where it's contained. Then here the scripts are there. This is example script. 30 query-rated queries are available here. Next is I have a documentation. This is architecture diagram. This is the test plan. You can able to do end-to-end testing. Okay. Next is a complete walkthrough. The people who doesn't understand how the application works, it is a step-by-step available. Anybody who can read the documentation, they can able to run the application without any difficulty. Okay. Complete documentation is there. They can able to test it out. The backend, I'm using a fast API. The fast API has a interface or a Swagger API. We can able to run all the APIs, right? This is the document which has all the information, how to test it out, each API, right? With the examples I provided. Okay. Let me walk through what are the main. Next is before going there, I have a real world use case which has the complete schema, which contains more than 1,000 records, which can cover pretty much everything. Okay. This is the dbeaver. This is where we are persisting all the information. Whenever the user query everything, we are persisting, so that when I show in the UI interface, you can able to see these details. Okay. Let me go into the components which are available. Okay. First one is Swagger UI. This is the fast API provide you the documentation. You can able to check whatever is needed. The way the architecture works is Fast API is a API provider which acts like a REST service provider. The front end is the React. React calls the API. API gives the data. The back end handles all the communications to the LLMs and then database or quadrant. Everything is done, right? This is the main backbone for this application. This is the uh, Fast API Swagger interface. Okay, these are the APIs which are currently available. It is the documentation, all the details are available. How can you test the each API? Okay. Next is the quadrant. Quadrant is the vector database, and then which internally uses the points, right? Whatever currently I injected, I parse the queries. Currently, all the details are available. These are the example queries which I tested, like around 30. Okay, you can see all the SQL queries. Okay. Next, I will go into, this is my admin interface. Admin interface has different screens, query, schema, manager interface. Then these are the queries which I tested. These are tested in the sense you can able to add it so that this information is available in the quadrant for for cosine similarity search. This is really helpful. Okay. Every request is going to log it here in the query logger. What it captured here is the question, what question it asks, what is the type, is it a select, join, aggregate, whatever it is going to identify. Then it is going to tell that what is the status, is it successful return, success, and then how many records it is written, then what is the latency, how long it took for generating a response. Right? Next is a guardrail. Guardrail is allow you to control what kind of operation the user can perform. They can perform delete, they can perform only select. Currently, we are only allowing select operation, as well as we are allowing maximum allowed records written is a 500. Even if the user has more than 500, it's not going to allow. Okay. Next is model configuration. User has the ability to change the database type, Postgres, MySQL, and SQLite. Currently, we are supporting Postgres database. Another good thing is in the fast API, I'm using Acme, which basically you can able to switch to the different database easily with the minimum code change. Okay. And then currently I listed out like these are the LLMs. We can change it, depends license key what you are mentioning. Currently I'm using Open API, and then temperature I'm using 0 because I want the repeat the answers again. That's the reason I'm using 0. You can able to change it. All this configuration can be affect without restart the server. Okay. Let me go through some of the tests for a user can ask. Okay. Let me go to the simple query. Previously, I ran it to test it out the simple SQL list all pending orders. Okay, this has written. Next is another simple query is show me the products that are out of stock. Right, it gave the results. Next, we will go into the simple aggregate function. Right, how many customers do we have? Right, aggregate function means that it aggregates everything and gives the simple result. Okay. What is the total revenue from the delivered orders, right? This is a simple, it is not straightforward, but it required a little bit aggregate functions like a sum, all kind of a max, that kind of operations are called aggregate. Okay. Next, we will go into the how many orders are there for status, order status. Okay? It provide you, right? How many are delivered, how many are shipped, how many are pending, cancel. These are the order status, right? Based on that, it is aggregating. Okay, this many orders are pending, this many orders are shipped, like that. Okay. Next, we'll go into the join operation. Joining means you're joining one or more tables, right? More than one table is joined to get results. What that means is the customer ID is in one table, right? Which is mapped to the customer table, which has a name like that. Uh, Here, the show all the orders with the customer name, right? In the order table doesn't have the customer name, but it only contains customer ID. In order to get the customer first name, last name, right? What we have to do is we need to join order with the customer table, right? We got the results. Next, we'll go into another join operation, list of customer by total amount spent. Same thing, okay? This is from a customer table, right? Next is what is the product being ordered more than 10 times, okay? Next, we'll go into the temporal queries. Show the orders placed in the last 30 days, right? Next, we'll go into the one more query. Show monthly orders count for this year, okay? This is for simple queries which covered from a normal SQL, then aggregate, then join, then temporal. Okay. Now what we are going to test it here is currently the guardrail is not going to allow the delete operation. Right. Let me test it out that scenario to prove that this is working. Right. Let me try with delete all customers. Right. Let me type. Let me enter. You get the you got the error message. Okay? That means the guardrail is working fine. Thanks for watching.